Go through with this, just a reminder for some of you that I do recommend that you pause this video and then you do take notes. Right, so this would be a good moment to pause and just copy this down as I go forward, as I scroll down, pause it again, take down the notes. So that way this is with you. Whether you're in my class or Ms. Adama's class, it doesn't matter. If you will do that, that would be awesome. That would be great. Okay, so 15-1, inequalities. Hopefully my handwriting is not too bad here. And what is an inequality? Before I show you what an inequality looks like, let's talk about what an inequality is. And in many ways, an inequality can be contrasted with an equation. Okay, we know that when we see an equation is saying that something is the same or has the same value as something else. For example, if you have something like 3x is equal to 17 or something, we're saying that this side of the equation is equivalent, has the same value or same magnitude as this side of the equation. That is what the equal sign means. They are the same. If this was a scale, that means they weigh the same. However, an inequality is not necessarily like that. Okay, an inequality is a mathematical statement, so think of like an equation or an expression, showing that one quantity or one side is greater than or less than the other. So it's actually showing you not that they're the same, but that one is bigger than the other. And you guys are familiar with some of these. For example, 2 is greater than 1, right? 1/2 is less than 3/4. Right? And there's ways that we can verify that and say that, but that's precisely, these are actually inequalities. Instead of having an equal sign, because they're not the same, we have inequality symbols. And there's 4 inequality symbols. There's technically 5 that I can think of, but 4 that I want you to be familiar with right now. And those are the greater than symbol, and we read it from left to right. So greater than, meaning that this side is greater than this side. All right, we have the less than symbol, which is facing the other way. So it's like saying this side is less than this side. We always read from left to right. But then, and you guys may have seen these in 5th grade, but the following might be a little bit new to you. We have greater than or equal to, and we have less than or equal to. Greater than or equal to, and less than or equal to. For example, x, which again, x is a variable, which we do not know what value that is, but we can say x can be any number that is greater than or equal to 7. All right, what this statement is saying, unlike an equation where we have something like x is equal to 7, when we have this, we are saying x is 7. Okay, we just found out x is 7. X cannot be any other number. But when you write an inequality, like we have down here, right here, we're saying that x can be any number that is either exactly 7 or greater than 7. So it could be 7, it could be 8, it could be 9, it could be 10. So there's really an infinite number of numbers that fit that description, but nothing that is less than 7, not 6.9 or 6. What do I mean by that? All right, well, let's look at some of these examples. And I believe some of these are from your assignment or from your textbook at least. Let's read this statement right here. The captain must be at least, notice that key word, at least 23 years old. The captain must be at least 23 years old. So what are we talking about here? We're talking about the captain's age, maybe like a pilot. So the captain of the plane must be at least 23 years old. All right, so can the captain be 22 years old? Would that be legal? According to this statement, no. Could the captain be 20 years old? Obviously not, because that is not at least 23 years old. Now, could the captain be exactly 23 years old? Yes. 24? Yes. 42? Yes. So let's write an inequality to show this. So the captain's age, which again, we don't know what his age is. So I'm going to put his or her age is, so I'm going to put an X. I don't know what it is, but it's being compared to 23. So X. And X, the age can be either exactly 23 or greater than 23. That is how the inequalities work. Notice that it's not saying that the captain must be exactly 23, but it can be that the age of the captain, X, can either be greater than or exactly 23 years old. That is how the inequality works. Let's look at the next one. All right. He or she, you can have female captains, right? He or she must have a minimum, notice this keyword right here, minimum of 1,500 hours, 1,500 hours, whatever that means. Well, okay, so we're talking about the captain's flight hours, or before they can become a captain. So that is what X is now. X is no longer talking about age, now it's talking about the flight hours. And they must have a minimum of 1,500 hours. Again, if they have less than 1,500 hours, so if their hours are less than, can they be a captain? No. It's saying, but can they have more than 1,500 hours? Yes. And if they have exactly 1,500 hours, does that work? Yes. That is the minimum. As long as they hit that, but no lower, but they could have more, then that works. So again, look at how this inequality is essentially translating this statement into an inequality, into this kind of expression. Let us go for the next one. Pilots can fly a maximum. What does max mean, or maximum? You know, if you're at max volume, you can't go any higher. Okay, so it has to be either that or less than, right? So the max is, for example, on a test, the maximum grade that you can get is 100. You can't get more than that usually. But you can definitely get a lower grade than that. Okay, so pilots can fly a maximum of 100 hours. So this time our variable, we're always going to have a variables, right? So I recommend you always start with like a X or some sort of variable. So X, what they can fly, I think this is per week or something, per week. And we're comparing that to 100 hours. And again, can they fly less than 100 hours? Yes. As long as they don't fly more, the max is 100. Can they fly more? No. So X can be less than 100, but can it be exactly 100? Yes. If they hit exactly 100, then they hit the max. Good. If they do more than that, then they are breaking protocol. That is not good. So notice how this inequality is showing this expression, or sorry, this situation right here. Let us do one more. Not use a different color. They may not fly. They may not fly. Okay, no more than 32 hours per week. All right, so different situation here. So their flight hours per week, X, hopefully you can see that. Let me use a darker color. Their flight hours per week are being compared to 32 hours. And again, it says no more than. So if it's not more than 32, then it has to be less than 32. Less than 32. Okay. However, can it be exactly 32? Well, as long as it's not more than. So yes, so it has to be less than or equal to 32. So I recommend you rewind this video if you kind of got it, but we're a little bit confused. You're not quite getting it there. But notice how I used the key words, at least, minimum, maximum, more than, to show an inequality, right? Okay, moving on. Now, we need to understand that the solution of inequality is different than the solution of an equation. When we were doing equations, ladies and gentlemen, when we were doing equations, remember, equations were telling us exactly what the answer was. For example, X has to be equal to 7, or 18 is the answer to the equation. That's saying that is the only possible answer. But when you see any one of these situations up here, for example, pilots can fly a maximum of 100 hours, okay? That means that their flight compared to 100 has to be either exactly 100, that's the max, or less than 100. So what would be the solution to this? What can X be? What can be the value of X? Well, X can be anything that is either exactly 100 or less than 100. So X could equal to 100, X could equal to 99, X could equal to 5. Anything that is less than 100 would fit this description. And I know that's going to be a little bit confusing. And so hopefully, as we go along, it's going to make a little bit more sense. But again, what I am saying to you is that we are no longer saying that X is only one value, but X, this is simply showing you all the potential values that X can be. All right, anything that is less than or equal to 100, or depending on what the inequality says. Okay, so before we go on, and I don't want this video to be too long, and again, I realize we're barely starting this, so you're going to see a lot more of this later. Let's talk about graphing inequalities. Let us graph an inequality. So here we have this inequality that x is greater than 3. So x can be any number that is greater than 3. So let me ask you a question. Can x be exactly 3? No, it has to be greater than 3. So how do I show that in a graph? So here I have this number line. That's what I mean by graphing. Well, I'm going to use an open circle. Ladies and gentlemen, anytime you have a greater than or a less than symbol, you're always going to use an open circle because you're saying, I am focusing on 3, but I'm not going to include 3. It's almost like there's a force field around that, and I can't get into it. All right, so I cannot select 3. 3 is not part of the solution. But x can be anything that is bigger or greater than 3. Notice that the inequality symbol always faces or is always open towards the larger one. So I'm going to highlight everything and I'm going to put an arrow going up, everything that is greater than 3. Now, if this had said x is greater than or equal to 3, then again, x can be any value that is greater than 3. But notice how this line in the bottom shows that it's also equal. So I'm not going to put an open circle. I'm going to shade it in. We're going to have a closed circle. So notice the difference between this one and this one. On the bottom, we have a closed circle because x can be either greater than or equal to 3. That's what that line means on the bottom. And on the top, it is just greater than. So I'm going to use an open circle. Okay. Now, obviously, if this had said x is less than 3, sorry, that's if this had said x is less than 3, then I would have an open circle. Sorry, that's supposed to be an open circle, but I would highlight to the left and just put an arrow to show that any number less than 3 works. And obviously, if x was less than or equal to 3, then I would have a closed circle because it can be equal to 3. Closed means I am selecting 3, it can be 3 or anything less than 3. All right. So ladies and gentlemen, hopefully you found this video helpful. And again, we're barely starting this. So if you're a little confused, that is okay. That is okay. But yes, feel free to ask me any questions or also whoever is with you in the classroom, and we will definitely help you. And so with that, I will leave you until next time.